In our last lesson, we were looking at solving exponential equations. In this lesson, we're going to be solving logarithmic equations. Now remember, the problem with exponential equations was that x was in the exponent. The only way we could get x out of the exponent was to undo the exponential by taking logarithms. Well, you probably already gathered that as we look at solving logarithmic expressions, we're going to have x in our logarithm. We need to get it out. And the way we'll do that is by using exponents. So, in our case, we're going to be looking at logarithmic equations. And just as logarithmic equations aided in removing the variable from our exponent, now exponentials are going to aid us in removing the variable from the logarithmic statement. So, let's take a simple one to begin with. Let's solve the equation, the log base 2 of x equals 25. Now, first of all, let's be careful here. Some people might say, well, I'm just going to divide both sides by the log base 2. But remember, this is not the log base 2 times x. It's the log base 2 of x. This is a unit. I cannot divide by the log base 2 because I'm not multiplying by the log base 2 on both sides. So I've got to find out a way to get that x out of our logarithmic statement. And in this case, it's a pretty nice way to do this. We'll remove x from the influence, let's say, of the logarithm by transforming this logarithmic equation into its equivalent in exponentials. And remember, that means that 2 to this 25 will equal our x. And so when we do that, we get 2 to the 25th equals x. Well, all of a sudden, we've just solved for x. Okay? And our answer, by the way, is a huge number because we've multiplied 2 by itself 25 times. It's 33,554,432. You didn't think it would be that big, would you? Now let's look at some that get a little more complicated. In our second example, we have the log, common log. Remember, no base is identified, so this is the common log, or the log base 10, of 3x minus 2 altogether as a unit equals 2. Well, once again, we can change this to an exponential statement if we say that our base, which is 10 right here, to the second power equals what we're taking the logarithm of, which is 3x minus 2. Notice all of a sudden, x is out of the influence of the logarithmic expression. And now we can solve for x as we normally would. So our next statement would be taking 10 to the second is 100 equals 3x minus 2. We will add 2 to both sides, and we will get then 3x equals 102. And of course, you know, to divide both sides by 3, and you will get x equals 102 divided by 3, or 34. And so if we looked at that, we would say then that the log of 3 times 34 minus 2, and it would equal 2. Let's look at a third example. In this example, we've got the natural log of x. We want to isolate the natural log of x before we change to our exponential form. And so consequently, we need to get rid of the 7 and get rid of the 2 on this left side of our equation. Well, 7 is being added, so to get rid of it, we easily subtract 7 from both sides, and we get the natural log of 2 times the natural log of x, rather, equals negative 1. But we can then take and divide both sides by 2 to get rid of the 2, and we will get then the natural log of x equals negative 1/2. Now, once we have isolated our logarithmic expression, Now we're ready to get the x out of the influence of the log. And we can do that by changing this. Now remember, this expression is written log base e of x equals negative 1/2. So e to the negative 1/2 will equal our x. And that's what we have in our next expression. And now it's just a matter of going to the TI-83 or 84 calculator, which we've done in the past, and hitting the second and natural log button to get e, and then put in negative 1/2 or negative 0.5, and you'll get 0.067 as your answer to this equation. And then we've got one more example to look at. Now this one's a pretty good bit more complicated because we have the log base 3 of x and the log base 3 of x plus 2. So x is under the influence of the logarithm in two different places in our equation. We're going to use a fact of logarithms that will help us to solve this equation. The first thing we're going to do is go backwards with one of our properties of logarithms. Remember, if I have 2 times the log base 3 of x, I can turn that into the log base 3 of x squared. And now I have 2 isolated expressions, log base 3 of x squared equals the log base 3 of x plus 2. Well, if the log base 3 of x squared is the log base 3 of x plus 2, it makes sense that x squared equals x plus 2, since the base is the same. Now, if one of these had been the log base 5, we would not be able to solve this equation the way that we have. Now it's a simple matter of solving x squared equals x plus 2. And you'll recognize that as a quadratic expression. We want to set it equal to 0, so we'll subtract x and subtract 2 from both sides. And now we'll try to factor or use the quadratic formula. And once again, in this case, I've naturally chosen one that will factor. I'm a wise math teacher. I didn't want to do the quadratic equation here, or formula. And so consequently, we get this is true when x minus 2 times x plus 1 is 0. And remember, that means that's true when x minus 2 is 0 or x plus 1 is 0. In which case, x is 2 or x is negative 1. Now let's go back and see if these will both work in our original equations. Well, if I go back up here to the top and I take 2 times the log base 3 of negative 1, if you're really sharp, you remember that I cannot take the log base anything, any base, of a negative number. Okay, and so consequently, that answer, even though we get it, it's an extraneous answer, is what we would say in algebra. And so consequently, x cannot be negative 1. So our only thing that makes this expression true is if x equals 2. And in that case, by the way, it's not very hard to see that 2 will work. If I take 2 times the log base 3 of 2, that will equal the log base 3 of 2 plus 2, which is the log base 3 of 4. But over here on the left side, remember, I can take that 2 that's being multiplied and raise the 2 in our logarithmic expression to it. And the log base 3 of 2 squared is the log base 3 of 4. So we've seen that if we're going to solve logarithmic expressions or equations, we must change them into exponentials so that we can get x out of the influence of the logarithm. In our next session, we're going to be looking at applications of exponential equations. Thank you.